All right, greetings everyone. The purpose of this video is to be the first part on our lesson for adding and subtracting rational expressions. And before we begin on this, I just want to say that these skills we're going to learn in these series of videos and on this assignment are not something that we'll necessarily be using in this course. But for those of you who will be continuing on to upper levels of math, these skills are really important and something you'll need to know. So that's why we're going over this. Okay, so before we get to explicitly adding and subtracting rational functions, or expressions, excuse me, let's first talk about how we add and subtract fractions. Because if you remember, a rational expression is more or less just a ratio, and a ratio is another word for a fraction. So let's look at these. So the first thing we have here is 2/3 minus 5/3. And recall that when we subtract two fractions, the first thing we need to make sure is that we have a common denominator. And in this case, we see that we have that since the denominators of both of these are 3, which means then we can just subtract the numerators. So what we can do on the top there is that 2 minus that 5, that'll give us -3. And we subtract, the denominators stay the same since they're common. So I have -3/3. And then after we complete that, we want to try to reduce as much as possible. So this -3/3 will become -1. And that's our answer there. Okay. Let's look at the next one. Now, the next one's a little different because in this case, we do not have a common denominator, right? Between 4 and 6, those are not the same. So what we have to do is figure out what our common denominator is. And when we do that, we want to find something called the LCM, which means the least common multiple. So we're trying to find a number that both 4 and 6 will go into. Whoops, sorry about that. That both 4 and 6 will go into. That's as small as possible. And I believe in this. And so what we're going to do is rewrite each fraction now with a denominator of 12. And then we have to rewrite the numerators the same way, right? So what we say is to go from 4 to 12, what did we have to multiply by? We multiplied by 3. So we'll also multiply the numerator by 3. So we'll do 5 times 3, which will give us 15 there. We do a similar thing with the 6 to 12. So to go from 6 to 12, we multiply by 2. So we do the same thing with the 7. We multiply that by 2, which gives us 14. So our problem of 5/4 plus 7/6 has now become 15/12 plus 14/12. And then we can add those. Again, we add the numerators. So the 15 and the 14, which would give us 29. And then again, the denominator stays the same. So it's just 29/12. And there we go. We can leave that as an improper fraction in this case, and it doesn't reduce. All right. So that's adding and subtracting fractions. As I mentioned, we can use a lot of the same principles if we're going to add or subtract rational functions. So let's take a look at that. So here now we have two sets of rational functions, or excuse me, rational expressions being added and subtracted. And I know there's lots of x's and numbers flying around, but the same principles can hold. So in the first set here on the top, notice if we look at the denominators, we actually have the same thing in the denominator in both functions, or both expressions. So we can add by just adding the numerators, right? So we can do x squared plus 1 plus 7x plus 9 all over, and then the common denominator stays the same. Okay. And then we can, on the top, combine the like terms. So first of all, I notice there's a +1 and a +9, so we can combine those. So that would give us x squared plus 7x, since those don't have like terms, plus 10, all over x squared minus 4. And now everything's as simplified as possible, and we're more or less done. Now we could stop here, but in some cases it'd be helpful to continue on. And so what we might do is look and see if our numerator and denominator factor. And it turns out that they do. In this case, on the top, we can unfoil, and that would become x plus 5 times x plus 2. In the denominator, the x squared minus 4 you may recognize from earlier in the quarter as a difference of 2 squares. So we can rewrite that as x minus 2 times x plus 2. And you'll notice in this case what we have now is there's both an x plus 2 on the top and the bottom. And since they're being multiplied by everything with them, we can cancel those out. And so we just have x plus 5 over x minus 2. And that would be our final answer on that one. Okay. All right, let's look at the second one. So in this case, we have 3v over v minus 4 minus v plus 8 over v minus 4. We again note that we have common denominators in both the numerator, in the denominator, which means we can just subtract our numerators. Now, when we do this, we need to be very careful because it's going to be the first numerator minus the second one. So this minus this. And so when we go to write the next step, we need to make sure that we do that. So we'll have 3v minus, I'm going to use parentheses so that I'm subtracting the entire numerator of the second one. And then, of course, all over our denominator, v minus 4. And then when we go to do the next step to simplify, well, notice that we have this minus sign outside of a set of parentheses, so we can distribute that. So this numerator will now become 3v minus v, when we distribute the minus sign to the v, minus 8, all divided by v minus 4. In the numerator, we can again combine like terms, so there's a 3v and a minus v. That would give us 2v minus 8 all over v minus 4. And again, as with the last one, since there are no more like terms in both the numerator and denominator, we might leave it at this. Or we could also notice that in the numerator, both terms here are divisible by 2. So we can factor a 2 out, so this become 2 times. We factor a 2 out of the 2v minus 8. I believe we're left with v minus 4 all over v minus 4. And now notice we have both the v minus 4 in the numerator and the denominator. The one on the top is being multiplied by the 2, so we can cancel those out. And our final answer just ends up being 2. Okay, and that's it. All right, that's it for this video. We'll continue on with more stuff in the next one. Thanks for watching.